Hello everyone. In this video we are going to canvas the cluster analysis data set. So we've got A through J, we've got 10 columns of data, and we've got 325 rows, of which 324 are going to be respondent information. Over here, I'm just going to highlight this in a yellow, doesn't really matter. We have what is called the offer information. And this one here, which I'm going to highlight just in orange, is the customer that bought this particular offer. Okay? So Smith, last name of Smith, and there's all kinds of problems with that. We'll talk about that later. But we've got offer number 2 was in January. The variety was Pinot Noir. It was 72 kilograms of minimum quantity have to be purchased. The discount was 17% off of the list price. The wine's origin was from France. Is it past its peak? No. False. Above average rain? Yes or no. Customer last name? Okay, again, that's the customer. Now, one reason there's a problem with this is we don't know who this customer is. Is it, Emmett Smith of Dallas Cowboy fame? Or is it Adam Smith of Wealth of Nations economics a couple hundred years ago fame? Okay, joking aside, of course we know it's not Adam Smith. But you want to be careful of that as a data scientist. If you are embedded with a marketing team particularly, you need to be careful of that. And this week in your discussion with your paper, you need to, again, work hard at thinking about this from a business perspective. So you'll see my note. Now, I didn't want to go on a soapbox there, but we have to be careful because sometimes we get too demanding as a data scientist. We think, oh, all the data has to be perfect. If it's not perfect, it's junk. Okay, I've talked about that before, junk in, junk out. But in this case, we're going to group customers together. Okay. And we're going to do this not necessarily to market to that specific individual, but to find groups of customers. We've got 32 products or 32 offers, and we've got 100 customers as a sample. Like, let's say we have 1,000 customers and 2,000 customers, whatever it is. We've got a sample here, and we're going to build a model to develop specific segments. So you might have heard of segmentation marketing, where we target flyers to particular individuals. Similar to what we did with the pregnancy information, where we might say, wow, we should send a flyer to this person because they're 98% pregnant, or we have a score of 98%. Okay, that's good, but it doesn't really talk about their similarity to other groups or other people more specifically. Specifically, if we're trying to cross-sell a product. A couple of you mentioned that a couple of weeks ago in your papers, the opportunity to cross-sell or even upsell. So you got them buying the milk, start selling them the chocolate syrup, right? Or you got them buying the bread, get them to buy the jelly. You got them to buy the basic $1.99 bread, try to get them to buy that $6 stuff that has all the seeds in it, right? Upselling. Got them in the store with a low-priced advertisement for a refrigerator. Now's your time to sell them a more expensive one with better features, etc. Okay, but we're going to do that in terms of looking at the similarities in behavior of different people. Okay, so Smith and Johnson, they might not have anything to do with each other. They might not know each other. They might be from totally different backgrounds, totally different socioeconomic backgrounds. One might work the first shift, the other one might work the third shift. One might be single, one might have a family of 10. whatever. But the data analysis, the artificial intelligence here, the unsupervised learning, the machine learning, is going to identify whether, in fact, Smith and Johnson are similar enough to be marketed to as a group. Okay, because gone are the days of setting up one mailer, one flyer, one coupon to hit all of your customers. We have the technology. You, as a student, becoming a master of understanding how this all works, we have those ingredients that help us identify, oh, maybe there's 5 optimal groups. Maybe there's 10 optimal groups. Maybe there's 3 optimal groups. How do we identify those groups and market to them so that we have a better bang for our marketing buck, our expenses? Because you got to think about it in terms of, yeah, an email is cheap, but what about the content marketer that had to write the paragraph? What about the graphic designer that had to come up with a cute, enticing banner? What about the person that had to create a digital coupon? What about the IT staff member that had to ensure that the digital coupon or the promo code in the website guaranteed that it was going to take 17% off the product, 34%, 47%, etc. So we want to make sure we get this right. So that's what we're going to do. We're going to look at whether they bought. This is our key. Which offer did they buy? Right? You're going to note that it's the same number as column A. The reason for that is because when we put this into SAS, it's going to want it separated. We could easily put like a 1 here, but SAS is going to want a variability in the data. And I'm going to explain that in a minute when we run SAS. Okay, so we don't know how many times they bought this offer. We just know that they bought this offer. Okay, we could create another variable, quantity purchased, right? Maybe you have that in your data set for your project. Maybe you have that in your data set at work. We could do just, just for fun, 1 to 5. It's just a random number generator. So, okay. So we could add that as a new variable. Now, I don't say we should do that because I didn't prepare us in the lecture to do that. But just keep in mind, as a data person, you don't know how many quantity you actually purchased. Okay? It's kind of a binary thing. We don't have a 1 and 0 here because all we have are purchases, right? We don't have, Fisher 0 for, offer number 1, right? We don't have Fisher for offer number 1 as a 0. This isn't binary, right? But it is when we think about it because it's a yes or no. If there is a number here, if there's a row here, then it's a yes. They did purchase that. Okay, so in those terms, it's kind of in your mind. I want you to think about binary yes and no's, 1s and 0s. Not that they bought it twice, not that they bought 24 of them, not that they bought 26 of them, not that they bought 30 of them, etc. Okay. So that's the data set, that's the canvas. Hello everyone, in this video we're going to play with our data in SAS Studio for Academic. I already uploaded my file and I've also imported it to my library. So I'm ready to start the tasks. Okay, so you might need to take a moment and pause the video and upload and then import your file. Now, historically, we've been playing with linear models and things like that. Now we're going to go into this cluster analysis tab right here, and we're going to do k-means clustering. K is number of clusters, and means is about using averages. We're going to use what's called the Euclidean distance, where we take essentially the distance between 2 points and plot them. And then we start comparing all kinds of other points to create a cluster. Okay, so we're looking at calculating the distances. So we're still doing linear, x, y, the distance. Think of it as terms of Pythagorean theorem, base times height divided by 2, things like that. Okay. It's also very important that you watch the first video where I walk through explaining what the data set is, and then also walk through that lecture that I created about using a deck of cards to explain the algorithm. If you don't watch those two videos and you jump right into the SAS, all you're doing is going through the motions. You're not actually starting to build upon previous knowledge about what you're actually doing. And that is what's more critical than anything here. Cluster analysis can be fantastic, it can be fun, it can be exciting, but you really need to understand this idea, this concept of distance. Okay? So how far apart is one customer from another based on their behavior? So make sure you watch those two videos before you start this one. Okay, assuming you did all that, you've uploaded and imported your data, we'll go to k-means clustering. We will find our file. Mine is called wine clusters. It doesn't have to be the same name as yours, vice versa. Okay. Which variables are we going to use in clustering? Okay, so we are going to use offer bought. Okay, we're going to use that to determine which clusters people belong to. Think of that as in terms of, yes, I bought that product. Okay, now we're going to compare that across 100 other customers to see if they bought that product. But here's the beauty of it, because you could easily do that, right? You could do a filter in Excel and figure that out. But here's the trick. Here's what the artificial intelligence is going to do. It's going to not only see whether Adam and Tina bought product 1, but what other products did they buy? And did they both buy those same products as well? And to a degree, it's going to say, well, Tina, Adam, Carrie, Elizabeth, they bought all the same products 75% of the time. So if there's 4 products, they all bought the same product 3 out of those 4 times. So it's not just about if Adam, Tina, Elizabeth, and Carrie all bought the same product every single time. We would love for that to happen. Believe me, that we would love for that to happen, because then that would mean that they're the same type of people, without any deviation. We could do one heck of a target market flyer to a group of people that are exactly the same. But in reality, there are so many beautiful things that make us all different, make us all decide what we want to do with our day. Do we want to buy Merlot? Do we want to buy Moscato? Do we want to not buy wine at all? All kinds of things you can imagine. What's the weather like today? Is there a holiday coming up? Do I even have any money to buy wine? Or at that price point? Maybe I don't like Chilean wine, so I'm not going to buy Chilean wine. I'm going to stick to Australian wine or French wine. So again, you got to think about those things before you even start smashing these buttons. Okay. If all you do is smash the buttons, then you're missing out on a lot of what we're trying to teach you ever since you started this program. Think about the data, think about the human beings, think about the decisions. How can you help them upsell or cross-sell, or more correctly stated, increase their happiness? Think back to your economics class, utils of pleasure, happiness, participating in a marketplace. That's what this is all about. So let's continue. If we go to options, there are several things that I want you to keep standard. So this is range. So what that means is it's just going to take the range of the numbers as is, without any special standard deviations. Okay, it's just going to subtract the minimum and divide the range. Okay, this here is where I want you to play. In this video, I'm going to do 3 clusters. Your homework is to understand everything I'm about to do, but do 5 clusters. So Sunday night, if you turn this in, and it's only 3 clusters, you won't get any points. Well, you'll get some points, but you won't get all of them. So you have to come back after this video is over, after you've practiced, come back and change this to a 5. Don't leave it at the default 100. Every time you log in, it'll be at a default 100. Change it to that 5, and we'll keep running the model. Okay. So minimum distance between the seed and existing seeds. This stuff here is so important for you to have watched that deck of cards explanation, because we're talking about the distance here. Minimum distance. So if you're saying, I want to make sure that every single observation is at least 1 unit of measure away, then I'm going to check mark this. Now I'm going to tell you right now this is useless, because we want the least amount of minimum distance. Now we could argue, well, why don't we put 0.000001, but boom, oops, it's actually looking for a number equal to greater than or equal to 0, and it's actually looking for an integer. So we don't want this. One reason we could use it is if we're trying to find people that are least like each other, or we have more space in between their clusters, if that makes sense. Because we could potentially have 3 clusters that are very similar to each other, and we might as well have just 1 cluster then. So I would not check mark this. I liken it back to that VLOOKUP function from Microsoft Excel. The last part of a VLOOKUP function is a 0, right? Reference, range, which column to bring back, and then true or false. Never in my life have I ever seen anybody consistently use anything other than the 0 there. Same thing here. Okay, checking versus unchecking. Update cluster centroid for each observation. Again, go back to that card video. If you notice in that card video, we updated the centroid each time, okay? But what we're going to do here is we are going to keep that centroid the same until we're done with each run. So that would be like the card video where I don't change the centroid with each card, but when we're done with our 52 card deck and we reshuffle and play it again. Okay, we're going to keep it stable here. In that video, that playing card video, I showed you that I changed that on purpose so that you could quickly see that the centroids can change. Okay, but keep this unchecked. This would be something like if I were to give you the specific assignments. The cluster 1 centroid is 1.72, cluster 2 is 3.92, etc. Maximum number of iterations. How many times do you want to run this? Well, if you check mark it, it's going to run at 1 time. Okay. I don't suggest check marking it. I'd suggest you keep letting it run until it's satisfied. But that could cause you to tie down your computer a long time. So I could see how companies might say, you know what, run it 3 times and then stop. Take whatever result is done at the end. Okay? Because maybe your computer power, your server, your data warehouse can't handle something like that. So go ahead and leave these all unchecked. Only change the 3 there. Okay? Output. You have a lot of choices to the statistics, the actual cluster centers. I like to do the assignments because we got to take this back to marketing. We have to assign each of our customers to a cluster. And then we got to tell marketing, hey, here's all the people that belong to cluster 1. Here's all the people that belong to cluster 2, 3, 4, 5, 6, 7, 8, 9, 10, 2 billion. If you run 2 billion clusters, I highly doubt you will ever run 2 billion clusters, but you could literally tell the program to run 2 billion clusters. Now, the problem will be you don't have more than 2 billion customers, so the program's going to say, I can't assign all the clusters. I can't assign, so it's going to have a problem. Just like if you were to have 10 customers in a spreadsheet and you were to say, hey, I want 11 clusters, it's going to error out on you. So put simply, each cluster has to have 1 person or 1 observation assigned to it at minimum. Okay. Well, we don't have to worry about that because we're only looking for 3 clusters here and we have 100 customers. Okay. All right, so we'll have that check marked. We will run this. Okay, so we've got our 3 clusters. This is where they were initially planted. Okay, what we've got here is cluster 1, 2, 3, how many observations that are in there. Okay, the deviation, the standard deviation, maximum distance, so this is the maximum from the seed to the observation, okay, to the cluster center. Okay, now we've got nearest cluster. So if you're in cluster 1, you're close to cluster 3. If you're in cluster 2, you're close to cluster 3. If you're in cluster 3, you are closest to cluster 2. Okay. Now, if you look even closer, see if I can zoom in. This is getting fun. My blood's already boiling at how much fun I'm looking at here. So, cluster 1, the centroid, so the center. So we've got a tie here, right? At least from the scoring. Cluster 1 is 0.357 away, the centers, each center. So the center of cluster 1 and the center of cluster 2. Now, the second one is 0.3568. It's really close, but no cigar. So in terms of how SAS reports this, it's decided that, they're a tie. Okay. Now, when it comes to cluster 3, since it can't say I have ties, I'm close to 1 and 2, it's actually taken that objective approach, and it's noticed the calculations here, and it says, oh, I'm going to award it to this. Okay. So this is beautiful because you want to see, as a marketer, this is beautiful and key because how close are each of these clusters to each other? I would argue they're pretty close. They are pretty close. Look at it in terms of this. In cluster 1, there's an observation that's 0.1557 away from its center. Okay, that is just under half of the distance between the 2 centers. Right? If I multiply this, I get 0.31, which is very close to 0.35, about 10% short. So these clusters, relatively speaking, are pretty tight. Okay, so think about that. We ran 3 clusters with 300 observations, and it did a nice job, but all these clusters are pretty close to each other respective. I mean, look at this one. Holy cow, it's the distance. Like this one has a bit of distance in it. So think about that for a minute. We have some pretty tight clusters. What do you think our marketing's going to do? What do you think our data people or data, vice president's going to do? What do you think our CFO is going to do when they hear about your little model here? Technically, it worked. Technically, it worked. But think about it from a business perspective. From a business perspective, if you've got a cluster analysis where your customers are apparently pretty close together, sure, yes, you've got 110 customers that are in one, 113, observations. Sorry, not customers, but observations. Nice spread. Seems unique. What this is saying is, if they're really tight like this, not too far apart, then maybe you should run more clusters. Break it out a little further. Scatter things out by adding 5 clusters, add 10 clusters. See if it breaks things out a little bit further, and you get one that says, I'm 0.9 away, I'm 0.15 away, I'm 5.6 away, and vice versa. These are pretty tight, okay? Not that they're not unique, but they're pretty close to each other, okay? Now, we do have things like total standard deviation, how many are within standard deviation, and then we've got the R squared. We want that number to be high, just like before. And the reason why, I wouldn't say that we have errors in our model, but what I would say is, since you have to assign everything to one of these three clusters, there's simply going to be some observations or some customers that don't belong in any of these three clusters, or they're so far off, they're the oddball, the ugly duckling that eventually will turn into a swan because we'll add more clusters. But we have to assign that one-off customer someplace within our three clusters. In other words, they're outliers. But it's pretty healthy. That R squared is close to 100%. That's pretty darn good. Now, is that because I personally curated this data to make sure we had some fun data to look at and play with? Absolutely, I did that. Okay. So here are the cluster locations. Here's the deviations between, remember the standard deviation between all the points. So love this report. I think it's a lot of fun. You can package this up, of course, like before. Now, what I want you to look at is this file that you ran. We got to go to the library. We got to grab this. We've got to export it. Okay, again, I'm at a big zoom on my computer now because I wanted to show you this data. So if you're like, wait, where's my button? Well, it's because I blew my file up. So we're going to download this now. And we've got some great data to look at. Okay, so we have all of our offer information, or we have all of our data about that offer or where it was. Now, this is why I was explaining earlier that we need to have not only offer there, but offer over here where we had, if you remember before, it was 224, 17, etc. It's because, I'll be honest, SAS overwrites that. Okay. And what we need to look at here is the clusters that they were assigned and the distance that they have. Okay. So let's just look at this for a minute. We're going to look at cluster one. Now we've got cluster one, and these are all the individual customers. Okay. Your job is to figure out what the relationship is between all these customers. That jigsaw puzzle. You've got the pieces, now you got to put them together. Okay. Now, cluster two and cluster three. So your job is to use this data here to see if there's any relationship. Okay. Now, one way that I like to do that, okay, is I like to take all the offer information into a new sheet, and I like to do, since we did three clusters, 1, 2, 3, and I like to do some count ifs. Count ifs, okay, the range, so this range here is the same as A2, and then go back here, the cluster assignment, and now you'll see why I put a 1 up here, is the same as this. So what this has just done, I know I did this very fast, is count if a customer bought offer 2 and they were assigned to cluster 1. That's why we did the count ifs with an S at the end. Okay, now we're going to have to do some careful freeze painting here. For example, I1, we're going to want to freeze the 1 because we're going to drag this across. And we're going to want to freeze the A from A2. So put a $sign there. And we're going to want to freeze the reference column AA and the Ks. Only thing that's moving is going down for offer and to the right for these things here. And I like to do some data inc here. Okay. I also would say copy paste special values if you're going to do this. So now, oops, little but I really hate that it auto sizes when you do the filter here. So now what you could do is you could do this. Now, one thing that I would have you do next is, I don't know if you know this, you've ever seen this in Excel, but you can take all this information and go to data, remove duplicates, because we have duplicates. We pasted over 300 rows basically. Hit OK. We'll have 32 unique rows, one for each offer. Okay. And what we're looking at here is, are there any relationships between these offers? If we had 21 customers buy this one and 14 buy this one, and they were all assigned to this cluster. So if I take these heavy hitters, usually you take 3 to 5, and go over to this data over here, is there a relationship with this data? Is there something in this data set that makes sense? There's something in this data set that makes sense. For example, with some of these heavy hitters, I'm seeing France lining up. Okay. I'm seeing December, November, October here. Does that mean it's the last quarter, the last group in the year? Right here, I'm seeing several Marches in a row. So you have to play with this. Now, I'll be honest with you, 3 clusters here, that's not enough clusters, and that's why I'm assigning you homework to do 5 clusters. So go ahead, have fun with this. Get to this point. Remember, I did the count ifs, and just have fun. This is the marketing part. This is the part where you go to marketing and say, hey, here's cluster 1. Here's what's being said about cluster 1. They're all in March. They're all in February, January, March. Don't really advertise to this cluster outside of January, February, March. And you could even say, well, I got a couple hits here, so include that. And the reason I say that is because you've got some good products here. You have product information here, right? So that's really how you use this cluster analysis. For me, cluster analysis versus regression, this is more investigative, right? You've had the algorithm do its work, do its mutating, do its centroid analysis, do its distancing, and now you get to decide, hopefully with education and study, you get to decide what you're going to tell marketing, what you're going to show marketing. Great, thanks.